What's up guys, Jay Bish here coming at you again with some ChemNerd content, isolation content, quarantine content, however you want to call it. Let's have some fun. Now, in the last video that we talked about, it was super short. We just started talking about those condensation type reactions. In today's lesson, we're going to be talking about substitution reactions. There are a stack of equations that are either going to be on the screen or in the notes, so please make sure you guys have pre-downloaded these notes, the PDF of these notes, and you are following along with the video as it plays out on your screen. I'll be using the iPad probably a bit more than usual, especially in the upcoming videos when we start talking about those longer chain carbon molecules, just because the visual representation is going to be much easier for you guys to actually see rather than me just talking about them. Here are some of the key ideas, these 5 points that are on the screen here. Here are some of the key ideas we're going to be talking about. Feel free to pause it, write those key ideas down now. I'll give you 3 seconds, and that's enough. Okay, so substitution. Definition. Substitution involves replacing one substituent on an organic molecule with another substituent. Generally, this happens with saturated organic molecules rather than unsaturated. Saturated means there's the maximum number of hydrogens. Okay, unsaturated doesn't generally happen. Okay, or it's less likely for there to be a substitute. Substitution of alkanes. The two different types are substitution with alkanes and haloalkanes. So alkanes being those saturated organic molecules and haloalkanes being the alkane with a halogen group somewhere. Now the alkanes, creation and formation of those haloalkanes, is due to one of those hydrogen groups on the molecule being taken away from that molecule and creating and joining in a halogen group. This is an example of that exact thing happening. As you can see, this alkane is reacting with this halogen of chlorine under UV light and then chloroethane and hydrochloric acid. So then we jump into the question, what are primary, secondary, and tertiary haloalkanes? Similar to those primary, secondary, and tertiary amides, as mentioned in a previous video, haloalkanes will either have one carbon chain, primary, two carbon chains, secondary, or three carbon chains branching off of that initial carbon molecule. Substitution of haloalkanes. Now these are those alkanes what we just created just in this last section where we've taken out one of these hydrogen groups, and we've replaced it with a halogen molecule. We're now going to look at substituting those halogen groups with different molecules. Now these different molecules include cyanide, hydroxide, iodine, and ammonia. You can also react them with acetate, hydride, and methanol, but we're not going to be looking at those ones today. So cyanide. Cyanide is this CN molecule, this negatively charged CN molecule. Heating a haloalkane under reflux with potassium cyanide in ethanol substitutes the chlorine at the end with a cyanide molecule, as you can see in this description here. So hydroxide, those substitution groups, so we're going to remove that halogen group now and replace it with a hydroxide group. Heating a haloalkane with potassium hydroxide in a 50-50 ethanol water solution, under reflux again, the halogen group is replaced with a hydroxide functional group. It is important to note in this one, guys, it is important to note that you require higher temperatures for this reaction to occur. Now, if you don't have those higher temperatures, the reaction will actually favor the haloalkane that you previously had, rather than that hydroxyl functional group. Third up today is iodine. Now, adding a solution of sodium iodine to a haloalkane in ethanol allows for the halogen functional group to be substituted by iodine. Now, the question you might have is, why would an iodine molecule substitute over chlorine or, in some cases, bromine? The reactivity flows from iodide down to bromide, down to chloride, okay? The fourth and final group we're going to be talking about today is ammonia. Now, heating a haloalkane with a concentrated solution of ammonia in ethanol in a sealed tube, the halogen will be substituted with that amine functional group. This can form some of those aforementioned mixtures of primary, secondary, or tertiary amines. And that's it for today, guys. That's it for chapter 10. We have actually finished that chapter 10 content. It is quite straightforward, so hopefully you're able to follow along, get some good notes in your textbook, in your workbooks. As per usual, please like this post. Drop a comment down below. Let me know if you have any questions, comments, queries, or qualms. It's a lot of Q's. There also are some great questions in the Check Your Learning and End of Chapter questions. Now, I have uploaded all of the questions and answers into Canvas for you guys to do. Please make sure jumping into Canvas and actually participating in those discussion forums. All of these notes are going to be available up on Canvas straight away, so feel free to download those. And until next time, keep safe, keep healthy. Peace.